Hello. Good afternoon, everybody. Thanks for having us again to speak on the main stage at FOSDEM. It's great to be here. My name is Guido. I'm a long-term FOSDEM attendee. I'm a Debian developer. In the spare time, I also work at Google. And we're going to speak today about Linux desktop on ChromeOS. The code name is Crostini. Myself, I joined ChromeOS a few months ago, so I couldn't miss an opportunity to come to one of my favorite conferences to speak for the first time in my life about Linux on the desktop. So what will we go through? We'll discuss a bit like this introduction, right? And then we'll go through a bit of getting started with ChromeOS and Crostini. We'll go through the architecture, and my colleague Dylan, who is in the Mountain View team that implemented the backend of Crostini and the virtual machine management on which it works, will explain the internals. And then we'll go through a small advanced usage demo, or failing that miserably, we'll go through slides that shows what the demo should have looked like in case things like go not right. So this is our plan. You've all probably heard of ChromeOS. This is a Linux-based operating system that is quite widely available, but is also geared at a cloud type of work based on Chrome. One of the most exciting things that happened to it was the development, or recently for people like us, was the development of Project Crostini, which is a Linux Debian container natively running, integrated into ChromeOS, so that you can run anything that you run normally on Linux in a ChromeOS machine, and you can give the ChromeOS machine to other people, or you can use it and deploy it in your enterprise with the advantages of a simple and managed operating system, while at the same time maintaining the flexibility of a Linux system. Given how widely available ChromeOS is, which is not like amazing in every country, but still in the US you can just go to a shop and buy one, right? Like very easily. I would say that this is probably the closest, most available Linux desktop that just like comes there, right? So it's an interesting development. So starting with Crostini, once you have a ChromeOS machine, is very, very easy. You go to your settings, you turn on Linux, or you search for the terminal and you click it, right? And then this is installing, and then you get dropped at a prompt, right? And then this is Debian. And that's it, right? So this is probably the simplest installation of Linux that I have seen. On Ctrl-Shift-P, you see preferences. You can like adapt like size of a terminal and so on. And then you can install your applications, install your own terminal, do whatever you want. Once you install applications, they are integrated in ChromeOS. So here we installed a few development environments, right? And then you can start them. Just like you click on Eclipse, it starts in the window, any other development environment, or your terminal and anything in the terminal, any other app, everything works. On top of that, file system and Google Drive sharing were integrated, so you can share a Google Drive folder with Crostini, or vice versa. You can access Linux files from the file manager inside ChromeOS, and so then you can save from your Linux programs inside, like Drive shared with Linux there, and then see it in Drive, see it on your other ChromeOS computer, all these kind of things. Or from ChromeOS, you can manage Linux. Clipboard integration works kind of. There are some restrictions related to the fact that we don't want Linux to programmatically access anything that runs on ChromeOS, so you have to manually paste things in. This is to avoid attacks in the Linux container that extract data out of ChromeOS without your wish. Okay. So networking works, and once you start something in the container, for example, Apache, you can just go to either Penguin Linux test, or for many ports, just on localhost, and you'll be redirected to the container where you can test your development results and so on before uploading. Okay, my clicker is misbehaving. Good. You manage your settings just inside the ChromeOS settings, and There's like right now in dev a few settings, there are more coming depending what we implement. I'll have to do it manually, sorry. Here. We have some roadmap of things that we're already looking at. USB pass-through so that you can share a USB peripheral from your ChromeOS directly to your container. Support for audio so you can play your favorite games, but also so you can like listen to things anyway, like audio integration. GPU integration also for any sort of development with 3D or anything else. And also Fuse is something that didn't work in the first version, but is coming in the next couple of versions. Working myself in ChromeOS Enterprise, I'm also going to mention about the enterprise and manageability features. So when you buy ChromeOS as a consumer, you won't see any of this. But if you buy a fleet of ChromeOS devices with enterprise management of them, then you can manage the whole fleet centrally from Google, or you can export your policies in another way, and they will all behave depending on that. So for Crostini, at the moment, we have only a few policies. There's a device policy to turn it on and off. So if you don't want any of your people to use Crostini, you can avoid it. Then if you turn it on, you can decide whether only members of your enterprise can use it and which users can, or whether a user that is logged into the computer, in case you allow friends or other people to log into the computer that are not your enterprise users, log in, whether they can also use Crostini or not. This is just really a small stub, of course, as you can see. There is more enterprise features coming to make the container controllable centrally, but we're going to talk about them when we have them and when we have designed them. This is what is coming relatively soon. I'm now going to pass on the microphone to my colleague Dylan, who's going to speak about the internals of the architecture of Crostini and how it came to be and what is inside. Thank you very much, and see you later for the demo.
Works? Hello? Hello?
Yeah, thank you. Thank you. All right, so ChromeOS is already kind of a desktop Linux. We run on a Linux kernel. We have a user space that's built from Gentoo's Portage build system. We run a slightly modified version of Chrome for Linux as our main UI. So a lot of times people look at me kind of crooked and say, you spent a whole lot of time making Linux apps run on Linux. And at their core, they're kind of right. There was a lot of complications in doing this in a way that preserved Chrome's core driving principles: speed, simplicity, and security. Security being the big one that we really didn't want to mess up. Chrome OS has been at the forefront of desktop security since it launched. And we didn't want to take any steps backward on that front to add this new feature. One of the key principles we have is that we don't let any unsigned native code access to our kernel. Like, there's too much kernel attack surface to expose to random code. So the only code that we run that isn't signed by us, that we're sure is safe, runs in a Chrome renderer process and is very well jailed. So to preserve that kernel protection layer, we decided that instead of trying to make these Linux apps happy running in a jail, we would just give them their own kernel and put them in a VM. The solution we ended up with actually ends up with 2 Linux kernels and 3 complete Linux user spaces. So if you look at the overall architecture layout, it looks like that. But actually, a little bit more like this. You can see we've got our 2 kernels. There's 3 user spaces, the main ChromeOS user space. There's a user space inside the VM, which basically is there to bootstrap up an unprivileged Linux container, which is our 3rd user space that the users actually interact with. We're using stock upstream LXD to start the containers, which is nice. It gives us a lot of flexibility, gives us a lot of pre-manufactured containers that we can run. And with that, we start a Debian stretch installation up top. We've got our installation, which jails the Debian installation. And then there's an extra boundary with the VM boundary, which is the boundary between red and blue in the picture. And that boundary is the most important boundary. And to make sure that was as secure as possible, we went and really evaluated how to make a virtual machine boundary that was as safe as Chrome's current security principles. And we looked at the available technologies, and we decided we were going to use KVM in the Linux kernel, but that we weren't super happy with the user space options that we had. So we started from scratch and wrote a new virtual machine monitor in memory-safe language. We wrote it in Rust, just to give the maximum amount of protection we could from guests trying to escape into the host. We called this new VMM CrossVM because we were not creative that day. So this was, the principle of this was that it was really focused on security first. Performance is important, boot up time is important, but nothing trumps security. Have to make sure everything is as safe as possible. So the good thing about this is whenever the guest needs to request anything from the host, the normal path is it pokes an event FD, something on the host side wakes up, and we have memory safe code written in Rust that does the parsing of all the untrusted buffers from the guest, etc. So we don't have memory overflows or weird exploits going on. To take that a little further, we also decided to run each emulated device in its own Linux process. So when CrossVM starts up, it's got one main process. It actually forks off a bunch of children that can run in independent jails. They run in independent sets of Linux namespaces with different views of the mount tree and with different access to different system resources. So the main benefit here is that our VirtIO random device, if it was to get exploited, wouldn't have access to the networking stack. Only the VirtIO network device has access to that. And if you exploited the block device, it couldn't get to the data in VirtIO random. So all of that combines to keep the guest away from the host. And that's great. That's really what we wanted. But in a perfect world, you would never need your guest to access your host, right? You could just keep that hard line there. But we really wanted to integrate things. We wanted to integrate the UI. We wanted to integrate files, sharing, and network. So we had to punch a few holes. And to do that, we added some host-side daemons to ChromeOS to help share things with the VM that we're running. The biggest one of those is there's a Wayland compositor built into Chrome now. And we share that Wayland interface into the guest. We've got a custom VirtIO device that lets us have a zero-copy display pipe from apps running in the container in the VM out to Chrome. So you can get really good frame rates if you're doing video decode or playing a game. We added something to manage the VM's life cycles. So Chrome by itself doesn't have privilege to start a VM. Again, just added a security boundary there. There's a separate process there which manages bringing up and taking down VMs as the user needs them. We added Cicerone here is really interesting because it's the part that integrates the UI bits. So if you install an app in your VM, it notices that there's a new app in your VM and says, hey, maybe I should put this icon in your launcher. So now you can click on that icon and it just launches your app. And that communicates over gRPC over vSock into the VM. Finally, we had file sharing access. So you can selectively, as Guido showed, select files you want to share with the VM. So hey, I've got this thing in an email in ChromeOS. I'm going to download it. It's in my downloads folder, and now I want to edit it because it's a C file or something, and I don't have a good web editor for that. So I can click on it, share it in. It gets shared over 9P into the guest, and then the guest can open it up and edit it in Vim or whatever they want. all these host-side daemons also need endpoints inside the guest, so they need somebody to talk to. So on top of our default Debian installation that runs inside the guest, we've added a few. I'll do this one first. We've added a few daemons that talk to the host, and they're aware they're running in a Crostini VM. The main one's called Sommelier, and it's used to help X11 apps run against our Wayland compositor, and to kind of bridge standard Wayland into something that works over VirtIO Wayland. We actually have to run 3 of these, one for standard Wayland apps, and then one for a low DPI and one for a high DPI, because most X11 apps are awful at running at high-res screens like we have on some Chromebooks. And in addition to that, we added Garçon, which is the guy that talks to the UI component outside of the VM. So this is the thing that notices when an application is installed and shuffles its icon out to ChromeOS, or gets poked by ChromeOS and says, hey, please launch this application, or please install this application. So the VM we run, we called Termina. This is the thing that starts inside the VM. So it contains the init for the VM. And we wrote a custom init that was, again, super stripped down, knows it's running on a ChromeOS machine, knows that its only job in life is to get LXD up and running and start a container and do some lifecycle management things. Once it starts, it brings up LXD. We've got one more daemon we wrote, which is there to kind of bridge standard LXC container commands out of the container and out of the VM and into ChromeOS, so that we can poke it with gRPC and it can talk to LXD over its native interface. The main advantage here is that all this VM side code is completely read-only, signed, and trustworthy, so you can always get and start up to this point, no matter how corrupt you blow up your container or anything. All this is all unmodifiable and all signed by Google as well, so that you can trust it as much as you trust any code on your Chromebook. Too far. Okay, so that gets you to the point where you can run our default installation. Our default installation is Debian Stretch. It's pretty basic. It suits my needs fine. It suits a lot of users' needs fine. Although I imagine there's a few people who want to do something different or want to explore more what they can do in this room. Some people like different distros. Some people like to run Mint and all this other stuff. And we've allowed you to do a fair amount of playing inside the VM. So we're going to try to do a demo of one of these more advanced usages now.
Thank you very much. I'll try now to do a quick demo of this. If it doesn't work, I do have some slides. I'm going to publish then the slides with basically screenshots of the demo, but now I'm going to try to do it live. Do you have an idea how I can just replicate the screen? Because it's going to be very hard. Do you know how to replicate the screen? Like we have one screen only? You want to hear it? Yeah, I want to hear it.
Yeah, click on this. Just search for this place. That mirror internal display, just checkbox.
Okay, cool. Thank you. Okay, so we've already seen on the screenshots how to just install it and do it normally, but if you want to interact a bit with ChromeOS, you can just press Ctrl-Alt-T, and this ChromeOS shell will pop up. Is it big enough? Should I maybe increase it a bit? I'll increase it a bit. Oh, okay. No. Okay, should be better. So once you have this shell, you can type a lot of different commands to see and interact with your ChromeOS system, right? I'm going to just type VMC, and this tells you how to interact with these virtual machines. VMC list should show that there is one Termina virtual machine. You can create more. There is not a lot of need because then inside each Termina, they all look the same, and you can create different containers. So right now, I'm just going to type VSH, and this allows you to join either a VM or a container inside a VM. If I type VSH Termina, this just connects me to the Kronos user inside Termina, and this Kronos user basically can run LXC, right? So if I do LXC list, it shows my virtual machines. On a normal installation, you'll just see Penguin, which is the default container which runs Debian, and its IP address, right? From this, you can also see, for example, the networks, right? Yes. And you can just use LXC in various ways to study your situation, like as you would normally, and as you can check in the man page. One thing we're going to try to do is list our remotes. And this shows you basically, these are the default remotes that are published in ChromeOS. You can add more. Images is like images on Linux containers. So if we use that, we should have a good amount of random Linux distributions. I'm going to list AMD 64 images that are available there. Yeah, good luck with the Wi-Fi. If it doesn't work, it's okay. I remember a few. I don't know if we had a network connection here or something. Okay, we're giving up on that step. On a good Wi-Fi, like when not everybody is downloading their updated apps at the same time, it works. From there, you can copy an image. So for example, LXC image copy, Alpine Linux, which is very small, on local. Luckily, I have already copied it, so it should work very fast, just checking. If it doesn't, I just move on. Okay, so it copied it successfully. It didn't have to download it because it already had it. Then I can go LXC image list. And I have some versions that I had already copied from before, but you can copy anything that you see in that images. There is Ubuntu, there is main, there's a lot of various distributions, and otherwise you can find your own container images and just put them there, right? Just adding another remote. Then from there, I can just launch a new container, right? So now I'm going to launch it for real. So I'm launching an Alpine 3.8 container still because it's small, and I'm going to call it Alpine 1. I have a few that were already running, but this one is new. Yeah. So it's creating it, and it started it. If I list now, I used to have Alpine 0, Alpine 7, and Penguin, where Alpine 0 and Alpine 7 I was just experimenting on, and now I have Alpine 1, and I can just connect to its console. Now I'm root on my new container. And of course, I need a bit of network, but hopefully. Otherwise, I have a container that is already configured. You know, what am I to do? This morning it worked, but everybody was sleeping after the partying yesterday. Unfortunately, in the afternoon, everybody's awake, and it fetched something. We have a bit of time. At worst, okay, so I now have my packages available. Then I can go apk add Apache 2. Okay, not too bad. Thank you. also open SSH. Maybe. Maybe we'll just use Apache too. Leave it. Okay, it's done. Then I can start them. I'll start SSHD. Sorry, no. I'll start Apache. I'll just add a user. Of course. It's for a demo. I would use a real password, I promise. I could also have changed, to allow direct root login without, let's not do that, right? Okay, cool. And now that we have that, I can go in my normal container, right? And then I can just go SSH on my new container, and that should automatically work. Of course, we trust it. And I'm in there. Or since I installed Apache 2, I should be able to just open Chrome. I don't know, it should in theory work at alpine1.linux.test. I haven't managed. Exactly. So I'll just go LXC list. Alpine11 was this IP address here. So I can just go in Chrome to my IP address, and it should just show me my default installation of Apache. This concludes. Thank you. Amazing. And of course, this is mostly meant for developers, so you can publish your dev things and then try them in Chrome directly. You can use it really for anything. You can run your little services, experiment, and so on. At that point, you are free both on the distribution side, deploy your containers, pretty much anything except the things that we're still working on that I listed in the roadmap. This concludes our talk. There is some time for a Q&A, and we're going also to leave you our contacts and our list so that, where is the present button? Here. So this is just what we've just done in the, really? Are you loading it from the network now? Okay, so thank you very much. If you have questions, let us know.
Can I say? Oh, hi. Art here. I have a little question.
Okay, run to the question directly.
Thank you. Before Crostini was released, I was using something else called Crouton, I think. It was like like a community for someone who made it in his leisure time. Did you collaborate it with him, or did you use a totally different approach than what he did?
Thank you. From what I know, Crostini was inspired by Crouton, but the approach was different to allow it to run in a non-modified, non-dev version of ChromeOS. Maybe Dylan can speak more about that, but that's the small gist.
Yeah, we have several of the crouton maintainer types are actually on our team and had done that. So they contributed a lot of ideas, and we're excited to see us basically make a verified mode crouton, which is what we started calling this, and hence the Crostini name.
Hey, I've played around a bit with it, and as far as I understand, the port forwarding stuff is only between the container and user space, and it's on. Okay. Okay. So I've played around with Crostini, and as far as I understand, the port forwarding is just between the ChromeOS user space and the container user space inside the VM. So there's no way for me to SSH in and out of my container to another device. Is that right? Or is there a way to do this?
Yeah, that's right. That's on purpose, at least for now. We haven't come up with a way we're happy with to expose ports from inside the VM to the outside world yet. Just, it makes us feel a little creepy, like we don't have any open ports now, and adding them is kind of scary from a security standpoint.
Thank you for that.
On the other hand, you can for sure connect from inside the container outside. You could do some SSH forwarding or other things if you need to. This is mostly meant, again, as a desktop user space use case. So, I mean, if you want to run an onion service on Crostini, you could, and it would work, I guess. But the idea there is like you connect from there from your own machine, or among all the containers, everything also works, right? So you can SSH between different containers on your machine and so on. You cannot create a network of ChromeOS devices that, I mean, unless you have some other layer there and so on. But that's not by default for these reasons.
I have two questions. One is how strong is isolation between containers? They are running in the same VM, or is it possible to have separate VMs for each container? And the second question about GUI integration. Is it possible to extract single windows or from application running inside those Linux containers? Or it's only just some full desktop something?
You can start multiple VMs and have n containers in each VM. I didn't quite catch the second part of that question. Any of them can display windows if you'd like. So they all get the connection to Chrome's Wayland socket. But you need to, if you're going to run a non-standard container, you need to go do the plumbing that has those special daemons I talked about running inside your non-standard thing, so it can talk to our slightly modified Wayland protocol.
Or, of course, you can port all of our tools for your favorite distribution.
I have a little question about security. You said that you're trying to keep your software as secure as possible. However, when you buy a Chromebook, the security update stops after 7 years, between 5 and 7 years. So how can you say secure? And is there a dependency between what you're proposing and also the ChromeOS you have on your computer?
Yeah, eventually they stop updating. Although, if you really want to keep using this ancient Chromebook, you can keep pulling builds and updating it yourself if you'd really like. And you can sign it yourself. Obviously, we're a big believer that the hardware is yours. You can go pull the right protect screw on your 7-year-old Chromebook and start signing your own things if you don't trust Google's signature even. So how secure it is really up to you if you want it to be, or you can do the easy thing and let Google worry about it and buy one computer every 7 years.
I have a question too. Does this work on a Chromebook that isn't in developer mode?
Sorry, could you say it one more time?
Does this work also on Chromebooks that aren't in developer mode?
Yes, it works in developer mode. Everything that works in regular mode works in developer mode. It works in normal mode by default, yes.
Okay.
Yeah, you don't need to be in developer mode. If you want to be in developer mode, you can be in developer mode. If you want to do some even wilder things, feel free.
So half my question was answered by the FAQ. It's not supported on the ChromeOS machine I have. So I'm wondering why, and if I did like try and build, do my own builds, like what would be stopping me from, what makes it difficult to support like a 2013 Pixel, a first gen Pixel, which has like all the horsepower you would need to do VMs, but Google has stopped updating.
Yeah, our goal is to get it to as many Chromebooks as we possibly can. Yeah, we really do want to bring it to as many Chromebooks as possible. There are some challenges on some of the older ones. Some of them don't run the newest kernels and don't have some features that we need. And updating their kernels is rather expensive because there's too many bugs in new kernels. And the combination of the old kernel with the recent Intel speculative execution issues has made it very hard for us to update some of those older big core devices in particular. So it's something we want to do. We're just trying to figure out how.
Could you say a bit about your approach about the GPU acceleration inside the VM?
We're working on it. It's a big chunk of work to get the GPU exposed into the VM in a way we're happy with from a security standpoint. But we do have people exploring that now. So hopefully someday soon. It's about as non-committal as I can be with the schedule.
I have a question about, over here, just about distribution of apps. I mean, if we have a Linux app that we want to make available to Chromebook users, but we don't want them to have to like bring up shells and go through that whole interface, is there a plan to have some sort of, you know, app store type of mechanism for installing apps?
Our initial pass here has been very focused on enabling developer use cases and not so much on app use cases. So today, that's not really super smooth, right? So if I just want to go click on an install package, it won't automatically get me through this whole setup flow. If I've gone through this setup flow and then I go click on I can double click on a .deb package and it will just install. But you still need to go through this initial setup, which is kind of a barrier, as this is still got a beta tag on it for some good reasons, and it's really only tested for these development use cases. We wanted to enable people to develop web pages, develop progressive web apps, these types of things on a Chromebook first, and then we're looking to expand those use cases in the future.
Well, I'd like to encourage that, so yeah, thanks.
Have you looked at the performance overhead of running everything virtualized? Do you have any numbers about it, or?
There is somewhat of a performance hit. It depends on your workload. The biggest things are normally I/O heavy operations that do a lot of VM exits. So if you're looking for like the absolute utmost performance from the hardware, it's not quite native, but it's really close to native, and it's been fine. I've been using it as my only development device for months and months, and I've been okay with it for things like building kernels, building cross VM, building audio servers, things like building Android. I still go to my big beefy desktop.
Okay, thank you.
So in your Apache test, it was connected via HTTP and IP addresses, and you can't open ports. You can't open ports, so Let's Encrypt isn't really an option for HTTPS. I'm wondering if there are any thoughts to making like a local Let's Encrypt kind of style certificate authority that maybe Chrome would trust, and some sort of way to create like local domain names that could then be used in that scenario?
Yeah, so for development, we trust the container like we trust localhost. So we're cheating a little bit on that. And that's probably good enough for the use cases where someone is developing a web page or a PWA. It lets you install PWAs, and that was our main goal. And we don't have a lot of plans to enable this as something you'd actually run a production service on, because it's still just a laptop, right? It's not. We're not looking to take over the server space here. Great. Okay. Thanks a lot, everybody.